Hello students, let's begin with a new lesson, work and energy. What does one mean by work? Look at these pictures carefully. In the first picture, you see a lady working. She's sitting at her desk, working, computing something. Lot many things are going on in and around her. In the second picture, you see a horse tied to a carriage and the horse is standing still. Do you think the lady who is sitting at her desk, maybe 24 lot of time, maybe 8 hours, has she really worked? As well as, do you feel that the horse who is carrying the load of the carriage is doing some work? No. Scientifically, or in relation to physics, we do not consider this as work done. Then what is work done? Look at the picture. The same carriage now has started rolling. The horse is moving. This is work done. So, scientifically, we say work is done when a force is applied to produce motion in the object. So, irrespective of how much time that lady at the desk is sitting, mentally she would have worked a lot, but as far as physics is concerned, since she did not move away from her desk, there is no work done at all. Think, if you do the entire homework within no time from sitting at your desk, all maybe for a 1 hour or 2 hours, do you think from physics viewpoint you have done lot of homework that day? So now that we know what is work, work is done when a force produces motion in an object. What are the factors on which work depends? Magnitude of force. I hope you remember what is magnitude. So work done by a force will depend on how much amount of force has been applied and the distance through which the object moves or the distance in which the object is displayed. Look at this picture. Person A rolling the cart to person B and to and forth. So in this case, both of them are applying some force and the object is getting displayed. So equally the work is done. Think, does it happen that you have applied force and yet there is no work done for you? Which means magnitude is there but object does not get displaced. Have you come across such scenario anytime? How should we compute work? How should we calculate work? We know that when a force is applied on an object, it can displace it. We say work is done. Let us see how to calculate it. I have taken the same image as in your NCERT textbooks. We have two objects lying on the table. A force is applied on that object and that object moves and covers some distance, say S. Let's label them the initial position of the object and the final position after the force has been applied. Assumptions. Let a constant force F act on an object. The object gets displaced in the direction of force through a distance S. These words in the direction of force are very, very important. Let work done be denoted by letter W. We know that work done in a moving object is equal to the product of force exerted by the object and the distance moved by the object in the direction. Hence, work is equal to force into displacement. If I put it in symbols, I get W is equal to F dot S. Remember, the unit of work is 1 joule, wherein I will define it as 1 joule of work done is 1 joule of work is done when a force of 1 Newton displaces an object by 1 meter. And if you want to find out its unit, you know the unit for Newton meter. 1 joule is equal to 10 raised to the power 7 ergs. Now how will you get this? For that you need to know the CGS unit. You need to remember that 1 Newton is equal to 10 raised to 5 times. Remember, if the distance moved is 0, work done is 0. I had asked you a similar question. Lot of forces in the previous slide. Lot of forces applied, yet no displacement, no distance covered. The object does not travel at all. In that case, work done is 0. Which means if you are just trying to push a wall, applying all your strength, all your mental strength, all your physical strength, yet the wall is not moving, which means how much ever time you apply force, it doesn't matter, you have absolutely not worked at all. So now we know what is work done. We know how to compute work. Work is a dot product of force and displacement. Also note that since force is a vector quantity and displacement is also a vector quantity, product of it comes out to be scalar, and hence work is only related to magnitude and not direction. So which means that you apply force on an object, the object will move from its place, and we say work is done. What are the types of forces? Works. First, we say positive work done. When the force is acting on an object, it displaces the object in the same direction. Look at this angle carefully. The angle made between force and displacement, theta, is less than 90, or it's acute angle. We say that the work done is positive. Look at the picture also. The boy is rolling the ball. Force applied on the ball and the movement of the ball both are in the same direction. I say work done is positive. When will work done be negative? When, let's say, the object is moving with uniform velocity in a particular direction and I apply a force in the opposite direction. In turn, I am creating a scenario of retardation. I say that the angle, the direction of in which the force is applied and the direction in which the object was moving is creates an angle and creates an obtuse angle, which is theta is greater than 90. I say that the work done is negative. Look at the picture. A goalkeeper, the ball is moving ahead towards the goal post. The goalkeeper tries to apply a force on the ball in the opposite direction of its movement. As a result, the ball stops, retardation. I say that the work done is negative. So although he has saved a goal, yet physics viewpoint, it's negative work. When will I say that the work done is zero? One case we've already seen, that the force induced does not cause any displacement at all, no displacement. I say that there's no angle at all between force and applied force and the displacement because the object has not at all moved. So I say that work done is zero. We've discussed this scenario in the previous slides. A person trying to push wall, how much ever force he applies, how much ever time for time he applies doesn't matter, how much ever exerted he gets doesn't matter. Physics viewpoint, he has not moved the wall. If he has not moved the wall, there is no work that is done. There is another scenario when I say that the work done is zero. That is when the force, applied force, and the displacement are perpendicular to each other. Have a look at this angle. Applied force and the direction in which the object is moving are perpendicular to each other, which means the angle between them is exactly 90. I say that there is no work that is done. Can you think of scenarios wherein you find that the applied force and the displacement of the object are perpendicular to each other?